Let's take a look at today's bell ringer. Which pair of expressions represents the area of the rectangle? In order to find the area of a rectangle, we're going to do length times width, or base times height. Base times height on a rectangle are interchangeable. When we're evaluating, because we have b plus 3 as one dimension and 6 for another dimension, it's important to remember that as we remove a variable, to put in parentheses to remind us to multiply the two parts. So I have 6 times b plus 3. This looks like C and like D. But then we also are looking for a second expression since it's looking for a pair of expressions. And what the problem is doing is it's using the distributive property to actually find the area. And the distributive property tells us to take the outside number and multiply it to the inside. So I have 6 times 1b plus 6 times 3. So that would give us 6b plus 18. And 6b plus 18 is located in answer C. Our second question, use the distributive property to find the value. Now remember, the distributive property takes the outside number and multiplies it inside. So we have 3 times 2x plus 3 times 8. 3 times 2x is 6x plus 3 times 8 is 24. So 6x plus 24 is our correct answer. Find x in the following equation. 40x plus 2,240 is equal to 3,220. In order to solve an equation, we need to find out what the value of x is equal to. And to do that, we need to remove all of the values away from x, beginning with the last thing that happened. So we have 40 times x plus 2,240. The plus 2,240 was the last thing to take place, so we are going to undo that by using inverse operations. So we're going to subtract the 2,240, but we're going to do that on both sides of the equation because we need to stay equal. A positive 2240 and a negative 2240 is my 0. That leaves me with 40x. And that is equal to 3,220 minus 2,240. So 3,220 minus 2,240 is equal to 980. So now we have 40x is equal to 980. We're multiplying the 40 and the x, so in order to undo that, we're going to divide both sides by the 40. And 40x over 40 is equal to 1, and that leaves us with x equals 980 divided by 40, which is 24.5. When these are multiple choice, you also have an option of substituting for your variable and solving the equation. This is a completely valuable method to use if everything given to you is multiple choice. And in order to do that, you would start with your original equation of 40x plus 2240, and you would try each individual answer. So I would start with A, and I would say 40 times 24 plus 2240, and I would put that into my calculator. 40 times 24 plus 2240, and I would get an answer of 3,200. That is not equal to 3,220, so that would tell me that answer 24 is wrong. Then I would go to my next one, and I would have 40 times 24.5 plus 2,240, and I would put this one also into my calculator, and I would find that it is in fact equal to 3,220, verifying my answer. So in case you forget the method of isolating the variable, you do have a backup method for this problem. And our last question, which expression is equivalent to 10c plus 7 plus 8c plus 26 minus 6? This is combining of like terms. And in order to combine like terms, we're going to find the same things that have the same variable. So starting out with our variables, we have 10c plus 8c. Notice the 8 takes the plus sign. And 10c plus 8c is 18c. I am immediately going to take off those two 7c's because I know that they're wrong. My next step is going to be combining all the coefficients. I have a positive 7, a positive 26, and a minus 6. And if I combine all of those together, I get a plus 27, verifying my answer as 18c plus 27. I hope you're paying attention to a lot of the bell ringers that we've been doing over the past couple of weeks. These are not just filler questions. It's not just busy work. A lot of this material is stuff that you were presented to in 6th grade, and this material does come up on tests and exams. So it's a good thing to pay attention and to try your best on these. Lesson 3-4 is what we're going to be working on today, and this is solving percent change and percent error problems. It would be a very good idea to get your interactive notebook out and use the page that was on there, because one of your boxes is specifically on percent change and the other one is specifically on percent error, and it tells you exactly how to set it up. Percent change on your sheet was told to be the difference of your numbers. And to find the difference, you're going to subtract them, and you're going to place that over the original, and that is equal to the percent over 100. This is if you're using the proportion, which is a really good method. And percent error is very similar to it because, again, you're going to find the difference of your numbers by subtracting them, and you're going to place it over the actual value and then set it equal to percent over 100. So while we do these, percent change and percent error are both going to require subtraction. Subtract your values to find the part. Your original or your actual value is going to be your whole. And then we're going to have your percent over 100 as well. And we're going to practice this throughout this entire lesson. Let's start with this question. Lita's softball team won 8 games last month and 10 games this month. What was the percent change in games the team won? And was it an increase or a decrease? That second question is kind of simple. She did 8 games last month and 10 games this month. We can easily see that from 8 to 10 is an increase. Now let's focus on the percent change. The first thing that we need to do on the percent change is find the difference of your numbers. So step 1, subtract your 2 values. And there is a change of 2 games. So the 2 is my change. It's going to take the place of the part in my proportion. So if I go and set up that proportion, the 2 is my part. It's going to go to the top. Now underneath it is going to be the original number. What number did we start with? Which one took place first? Well, the 8 games last month happened before this month. So I'm going to put the 8 as my whole. And I am trying to figure out what my percent is. So we can rely on our proportions to help us as well. And let's go and work this proportion out as we do this. We're going to do 2 times 100 and 8 times p. So 8 times p is equal to 2 times 100. That gives me 8p equals 200. And now we want to figure out just the percent, so we're going to divide both sides by the 8. And we are going to find out that p is equal to 25%. Using proportions is an easy way to do this. If you are a fan of the equation, that's also extremely simple when you're looking for the percent, because in order to find your percent, you're going to take your part, divide it by the whole, and then multiply it by 100. Let's try it with this question. My part was 2, and if I divide it by 8, that gives me 0.25, and then if I multiply that by 100, I also get 25. So you can use your equation to get the same answer. Okay, our next question. What is the percent change in the price of a gallon of gas to the nearest whole percent? Is it an increase or a decrease? Well, looking at our values of our gas, we have 3.499 and then 3.079. This is an obvious decrease in numbers. Now, going back to our formula, our first step in finding percent change is to find the difference of the numbers. So we need to take 3.499 and subtract 3.079. So 3.499 minus 3.079 gives us a difference of 0.42, a change of 42 cents. And this is going to be the part, whereas I'm going to put it over my whole, and that's going to be my starting number, the 3.499, the number that came first. And I'm going to use this to find my percent. You can cross multiply this one, or you can remember that part divided by whole times 100 is equal to your percent. And I kind of like that second method. So we have 0.42 divided by 3.499, and we're going to multiply that quotient by 100, and we end up with 12.00342, and it continues on. But if we go back and read our problem, it says to the nearest whole percent. So we're going to round it to a whole number and find 12%. This was a 12% decrease in the price of gas. Okay, several students measured a 25 millimeter long nail and wrote the measurements shown in the table below. Whose measurement had the greatest percent error? And we're going to round to the nearest percent. Percent error is very similar to percent change because the first step that we have to do is we have to find the difference in the values. So let's start with Lane. Lane measured 26 millimeters. The nail was actually 25 millimeters long. That is a difference of 1. I'm going to put that over the original, the actual size of the nail, which was 25. And then I'm going to multiply by 100. So 1 divided by 25 times 100, and I get 4%. So Lane had a 4% error in his measurement. Let's go to Tanisha next. Tanisha measured 23 millimeters. Well, it's a 25 millimeter long nail, so she was off by 2 millimeters out of those 25 actual. So I'm going to divide and multiply by 100. So 2 divided by 25 times 100 will give me 8%. Next is Juan's. Juan was exact. If you notice, it's a 25 millimeter long nail. He nailed it. There was no difference. He has absolutely no error in his measurement. Now the question is, whose measurement had the greatest percent error? And by looking at our information, Tanisha had the greatest percent error at 8%. All right, Using these three examples of finding the difference and putting over the actual in order to find your percent error and your percent change, I want you to practice a few problems on your own and then check them against answers that I put on. So on page 161, I want you to do questions 7, 8, 9, 10, 11, 13, and 14. I want you to continue practicing the exact same pieces of information because percent error and percent change are done the same way. Your first step is to find the difference in your values, and you find your difference by subtracting. Put it over the original occurring number or the actual number, in case you're working on percent error, and then you set it equal to percent over 100. Practice these few problems that I've given you, and I'll upload the answers here in a couple days. If you have any questions, I've given you an additional help video link and step 5 on Canvas. It is a really great series of videos, and when you click it, the teacher who does this, Mr. McLogan, has a series of percent questions that you can look through, and he breaks it down really well in case what we've gone over isn't enough. And if you have more questions, get on after school tutoring or get on virtually when I'm on there at 2:15 each day and bring your questions and we'll go over them. I'll talk to you soon.